All right, so I'm going to do a few questions from week two's homework. All of these are going to come from week two homework 2, questions 7, 9, and 13. And these are just questions that students in the past have maybe struggled with a little bit. So I thought I would do them on video so that we could talk through them. All right, so question 7. It says, use the information listed below to solve parts A through H. Suppose that the demand and price for a certain model of a youth wristwatch are related by the following equations. So I have price equals D of Q equals 28 minus 2.25Q. So this is a demand function where P is the price in dollars and Q is the quantity demanded in hundreds. That will be important, in hundreds. Find the price at each level of demand. Answer parts A through D. Find the price when the demand is 0 watches. So we want to find P when Q is equal to 0, right? So P equals 28 minus 2.25 times 0. So we get exactly 28. All right, that was part A. Part B says find the price when the demand is 400 watches. Now let's just take a look. If I plugged in 400 there, that would give me some negative value for price. But remember, we said that the quantity demanded was in hundreds. So our value for Q is not 400, it is 4. So we want to find P when Q is 4. So P equals 28 minus 2.25 times 4. 2.25 times 4 gives me 9. So I have 28 minus 9, which gives me 19. So the price is $19. Part C, find the quantity demanded for the watches when the price is $10. So this time we want to find Q when P is 10. So P is $10. Find the quantity Q. All right, so 10 is equal to 28 minus 2.25, pardon. So I'm going to subtract 28. So I get a negative 18 equals negative 2.25. So 18 divided by 2.25 gives me 8. Oops. So Q equals 8, but again, that is in hundreds, so that's 800 watches. All right, then part D is graph 28 minus 2.25Q. Well, we know we have a negative slope, so we can cross out B and D. And then what we're gonna do is we're just gonna try to look closer here at these graphs. So if we're looking 5, 10, 15, 20, 25, 30, it looks like these tick marks are representing 5. So if I look at this one, 5, this part C, that's 5, 10, 15, 20. So that looks like it's 20, 5, 10, 15, 20, 25. So it must be A because my y-intercept is 28. All right, now they're going to give us a supply function. So for the next questions, we're going to use a supply function. Suppose the price and supply of the watch are related by the following equation. Whoa. Where P is the price in dollars and Q is the quantity supplied in hundreds. I brought treats today, so maybe I can distract my dogs. Of watches, parts E through G. Find the quantity supplied at a price of 0. All right, so we want to know, find Q when P is 0. All right, so 0 equals 1.25 Q. That means Q has got to be 0. So 0 watches. So now we want to find Q, find the quantity supplied at a price of 14. So P equals 14. We want to know Q. So I have 14, we're in that room, 14 equals 1.25 Q. So 14 divided by 1.25, and that's 11.2. But this is in hundreds, so we're going to multiply by 100, and that gives me 1,120. All right, that's part F. Part G says graph both the demand and supply function on the same graph. Well, we already know what the graph of the demand function is from part D. So we know it's not that one, and we know it's not that one. And so it must be this one right here, because I think that's the graph that they gave us that was wrong in the first part. Now, it says given the demand function is what it was given before, and the supply function was what it was given before, find the equilibrium quantity. And that's when the supply and the demand are set equal to each other. So 28 minus 2.25 Q is equal to 1.25 Q. I'm going to add 2.25 to each side. So 1.25 plus 2.25 is 3.5. So I have 3.5 Q equals 28. 28 divided by 3.5. And that gives me 8. All right, so that quantity again, multiplied by 100 is going to give me 800 watches, and we want to know what that price is. And both of those supply functions and demand functions give me price, so I can plug it into either of those. So let's just go ahead and plug it into the supply function. So price is equal to 1.25 times 8, which is $10. So our equilibrium price is $10. All right, so that was question number 7. Let's move on to question number 9. It says to produce X units of a religious metal costs C of X equals 18X plus 48. The revenue is R of X equals 26X. Both cost and revenue are in dollars. Find the break-even quantity. All right, the break-even is when cost equals revenue. So we're going to set revenue equal to cost. So our revenue function is 26X, and our cost function is 18X. Whoops. Plus 48. All right, Triggy is just needing some attention. All right. So let's subtract 18 from those sides. I get 8X equals 48, and that should give me 6. So 6 units is going to give me what we need to break even. And then it asks me to find the profit for 430 units. So we need to come up with the profit function. And remember, profit equals revenue minus cost. So my profit function is going to be R of X minus C of X. And my cost function is 8. Whoops. My revenue function is 26X. My cost function, make sure you have that in parentheses so we distribute our negative sign. My cost function is 18x plus 48. And I have 26x minus 18x, which is an 8x minus 48. All right, so that's my profit function. So find the profit from 430 units. So P of 430 equals 8 times 430 minus 48. Eight times 430 is 3,440 minus 48 is equal to 3,392. So our profit is $3,392. And then lastly, part C says, find the number of units that must be produced for a profit of $80. So we are going to set our profit equal to 880 and then solve for X. So I'm going to erase this part and then move our profit function up. All right, so 80 equals 8x minus 48. 80 plus 48 is 128 divided by 8 gives me 16. So 16 units is going to give me the profit of $80. All right, so that was number 19. And then lastly, we are going to look at number 13. The manager of a restaurant found that the cost to produce 100 cups of coffee is $11.24. The cost to produce 500 cups is $50.84. Assume the cost is a linear function of X. The number of cups produced. Answer parts A through F. So the first part is to find a formula for the cost. So what we have is we have 2 points, right? We have the number of units, X, and the cost, 1124, right? We also have the number of units, 500, and the cost, 50.84. And we want to come up with the linear equation, all right? It should look like C equals mx plus b, where my slope, m, is going to be the change in cost over the change in units. All right, so my change in cost is going to be 50.84 minus 11.24. And my change in units, 500 minus 100. So 50.84 minus 11.24 is 39.6 over 400. And the decimal, they say use integers or decimal values. I believe this is going to give me a decimal value. Notice I have a decimal within a fraction, which I can't leave. So I need to leave it as a complete decimal or change it into a fraction. But they say leave as an integer or a decimal, so I should change it into a complete decimal. So 39.6 divided by 400 is equal to 0.099. All right, so that is my slope. Now I still need to figure out what my y-intercept is. The way that I choose to find my y-intercept is I'm going to plug in my point and my slope and then solve for b, right? So I'm going to choose the first point. You can choose either point. It doesn't matter. So 11.24 equals m, which is 0.099, x, which is 100, trig plus b. All right, so I have 11.24 minus 9.9 is 1.34. So my cost function is 0.099x plus 1.34. And so let's just think about it like we talked about in class. We had a variable cost and we had a fixed cost. So this is going to be my fixed cost. And this is going to be, whoa, and this is going to be my variable cost. All right. So it asked me what is the fixed cost? Oh, 1.34. We just talked about that. So here is my fixed cost, 1.34. Part C, find the total cost of producing 1,100 cups. All right, so that's for X equal to 1,100. So C of 1,100 is 0.099 times 1,100 plus 1.34. 0.099 times 1,100 plus 1.34. I'm getting 110.24. So $110.24. The total cost of producing 1,101 cups. And that is plugging in 1,101. Let's try that again. Plus 1.34. 0.099 times 1,101 plus 1.34. And I'm getting, thank you. I'm getting 110.339. They tell us to round to 2 decimal places. So that would be this decimal place right here. So I should get 1,000 or 110.34. So it says find the marginal cost of the 1,101st cup. All right. So now we talked about this. The marginal cost is the cost of producing an additional one, right? And if it is a linear function, it is exactly just the slope. All right. Or you could think about it as the difference between the cost of these two, right? So the cost of 1,101 and the cost of 1,100. So that is 110.24 minus 110.34. Except for I put them in the wrong order. Let's try that again. But I guess they're going to use the exact 3.39. So 110.34 minus 110.339. Uh-oh, what did I do? Oh, it's 2.4. And I get, man, I did it wrong again. Sorry, 0.339 minus 110.24. All right, so this is giving me 0.099. All right, now this is in cents, so I need to move my decimal place. So it's 9.9 cents. What is the marginal cost of any cup? Well, the marginal cost, again, it's linear, so it doesn't matter if it was the 1,101 cup or if it was the 1,000,000th cup or the 5th cup. It's always going to be the exact same because this is a linear function. Right, and then the last question is, what does the marginal cost of a cup of coffee mean to the manager? It is the cost of a cup of coffee producing one additional cup. All right, so one more cup. All right, so sorry about the confusion of this one. I just kept writing it down wrong, in the wrong order. But that is some of the questions that people have found more difficulty with. So I hope that was helpful, and have a good evening.